3.
Hi everyone, my name is Noe, and today I'm going to be covering question 3 from the 2015 FRQ. Okay, so let's begin by reading the question. Johanna jogs along a straight path. For 0 is less than or equal to t, and t is less than or equal to 40, Johanna's velocity is given by a differentiable function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table value. Okay, so if we take a look at our graph, our t is represented in minutes and v of t is represented in meters per minute, or her velocity. At time 0, her velocity is 0. At time 12, her velocity is 200. At time 20, her velocity is 240. At minute 24, her velocity is negative 220. And at minute 40, her velocity is 150. Okay, so if we take a look at 3a, use the data in the table to estimate the value of v prime of 16. If we look at the table, we can see that 16 is in between 12 and 20. And v prime of 16 is basically just the derivative of v of 16. So to find the derivative, we can find the slope between the points 12, 200, and 20, 240. Okay, so to find the slope, we can do v of 20 minus v of 12 all over 20 minus 12, which equals 40 over 5, and then can be simplified to 5. So in the end, we're left with our estimate v prime of 16 equals 5. 3b. Using correct units, explain the meaning of the definite integral absolute value of v of t dt from 0 to 40 in the context of the problem. Approximate the value of absolute value v of t dt from 0 to 40 using a right-Riemann sum with the 4 subintervals indicated in the table. So before starting the problem, we have to remember that velocity equals distance over time. So if we were to graph our velocity function and we were to find the area under the curve, which can also be represented by the integral of the velocity function, we would end up with our total distance traveled. So from that we know that the integral of absolute value of v of t dt from 0 to 40 represents the total distance Johanna traveled in 40 minutes. Alright, so we know that the integral of absolute value of v of t dt from 0 to 40 represents total distance because of the absolute value placed around v of t. We know that the absolute value helps us find the total distance traveled because if you had negative velocity and you found the area under the curve, that distance would subtract from your total distance traveled and you would end up with displacement, which is the distance traveled from your starting point, which is not total distance traveled. So with our absolute value around v of t, it would change that negative velocity into positive, and when you find the area under the curve, you end up with total distance traveled. Okay, so for the second part of 3b, we have to approximate the value of absolute value of v of t dt from 0 to 40 using a right-Riemann sum with the 4 subintervals indicated in the table. Since we're using right-Riemann sum, we're going to have to start at the second point. So our first rectangle, to find the width, we have to do 12 minus 0, which will get us 12, and we will know that our first rectangle will have a height of 200. So the area of our first rectangle, we can find it using the absolute value of 12 times 200. For the second rectangle, to find the width, you have to do 20 minus 12, which gets you a width of 8, and that rectangle will have a height of 240. Our third rectangle, you do 24 minus 20 and you get a width of 4, and you multiply by the height of 220. And for the fourth and final rectangle, you do 40 minus 24 and you get a width of 16, and that rectangle will have a height of 150. So if you multiply everything out, you get 7,600. So from this we get an estimate that Johanna traveled around 7,600 meters from our right Riemann sum. 3C. Bob is riding his bicycle along the same path. For 0 is less than or equal to t, and t is less than or equal to 10, Bob's velocity is modeled by b of t equals t to the third minus 6t squared plus 300, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. Since acceleration is the derivative of velocity, all we have to do is find the derivative of b of t. So we get b prime of t equals 3t squared minus 12t. But since we want to find Bob's acceleration at time t equals 5, we plug 5 into b prime of t, and we get b prime of 5 equals 3 times 5 squared minus 12 times 5, which simplifies to 75 minus 60, and then we end up with b prime of 5 equals 15. So now we know that Bob's acceleration at t equals 5 is 15 meters per minute squared. 3D. Based on the model B from part C, find Bob's average velocity during the interval 0 is less than or equal to t and t is less than or equal to 10. To find Bob's average velocity, we can do his ending velocity minus starting velocity all over his ending time minus his starting time. This can be represented by b of 10 minus b of 0 all over 10 minus 0. From b of t, we know that b of 10 equals 700 and b of 0 equals 300. So now you plug in 700 and 300 into the equation, and you get 700 minus 300 over 10 equals 400 over 10, which simplifies to 40. So Bob's average velocity during the interval from 0 to 10 is 40 meters per minute. Alright guys, I hope you understand how to do problem 3 from the 2015 FRQ. If you guys want similar problems to this one, you can go try the 2011 FRQ problem number 2 and 2012 FRQ problem number 1. Thank you for watching.